of this moment. So this is the last problem, number 5, in relation to gas stoichiometric calculation. Okay, something like this. Okay, guys, this is the last. Okay, I was obsessed in solving, different problems. But anyhow, okay, I will not repeat the problem that I solved already, and this is really first time. Let's try. Okay, like that. So I have to take down the answer, and then I have to compare. If it is correct, then my solution will be correct also, right? Okay, or else we need to rework. Okay, something like that. Okay, guys, last problem of the day, of the night. Okay, solid magnesium nitride. Can you see the whiteboard again, guys? Solid magnesium nitride reacts with excess liquid water to produce ammonia gas and solid magnesium hydroxide. Okay, duha akong magnesium. Okay, where's the other magnesium? Okay, if 47 liters of ammonia gas was collected at 300 Kelvin at a pressure of 1.6 atmosphere, how many of the magnesium nitride was consumed in the reaction? Okay, I think it's gonna be how much. That's how many, or grammar, right? How much of the magnesium nitride was consumed, right? Because many, it talks about pieces, units, quantifiable parts by parts. Match is the amount in terms of the volume, the mass, like that. So, wrong grammar in question in the first place. Okay, we need to change this by how much. Okay, like that. Okay, now. Okay, so it's very pretty obvious in this question that this is no longer obeying the standard temperature and pressure because we have 200 Kelvin and 1.6 atmosphere. So it is no longer HTP, so you couldn't expect to use the 22.414 liter of a gas occupies for every 1 mole of an ideal gas. Because we have a gas here, ammonia also. Okay, forget that for a while. Let's TP because we have special data for this. Okay, now we have to understand, guys. Okay, I'm going to teach you that the stoichiometric chemical reaction really is an actual. Okay, not theoretical. Again, chemical reaction is an actual, not theoretical. Okay, other formulas, equations are highly theoretical. Okay? You get the point. So meaning to say, if you will use this chemical reaction, this is really actual. The products are actual. Okay, something like that. Now, this, for example, there are lots of formulas, right? Ideal gas equation, PV and RT, Avogadro law, like that, whatever, Bohr's law. These are all theoretical. You get the point? Theoretical. And then chemical reactions you can obtain there are all actual. Okay? Stoichiometric amounts in chemical reaction. And this is you're going to know. Okay? Because in the actual, it really focused on the final chuvas. Final. Okay? What will be the final blah blah blah? What will be the result of the upon the reaction of the blah blah blah? What will be the grams of the blah 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 in the product? Meaning actual, the last, the final. Okay? That is the identification. Okay? So you will normally focus on the chemical reaction if trying to solve for the blah blah blah, blah blah blah, blah 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 result. Okay? Meaning 2. Let's say V2, M2, final. Okay, final. Not the initial. But the theoretical will focus on the initial. Okay? Not the final. Okay? I teach you because sometimes problems are being mixed. Okay? Being mixed with a certain standard formula and equations. And at the same time, you have to go to the stoichiometric relationship. And at the same time, you will use the dimensional analysis conversion way of solving the problem. So it's multiple na talaga siya. That's why let's make it clear that stoichiometric chemical reactions are actual. You get the point? Okay. In this equation, you see so many data. Okay, like that. Okay. So this 4.7 liters, 300 Kelvin, and 1.6 atmosphere, these are all basing on the theoretical. Okay, theoretical. Not on the actual. Okay? Theoretical data. Something like that. So you can either use a lot of formulas here just to express the result, and then it will be used later to the stoichiometric relationship, which is the actual. You get the point? That's why if you can remember general chemistry lecture, that we have also percentage yield. Okay. Ako lang i-connect is equal to the actual yield. Okay, actual yield over the theoretical yield. Okay, the theoretical yield. Now, times 100. Okay, the actual yield here is based on the chemical reaction exclusively without question. Okay, and our theoretical yield will be based on the data presented as well as the standard formula used. Okay? So that we will not be lost in the succeeding, problems in stoichiometric chemical calculations. It's always like that. Okay? You get the point? So that we will not mix up. Okay, let's agree. So that we can solve another problems also, we will understand in that way. Okay? Now we have a solution problem here, right? Okay. Now, since I said theoretical and formulas, and then you try to extract, there's a lot of physical properties here. You have the temperature, you have the pressure, you have the volume. So you need to think of the formulas, theoretical, right? Before proceeding to the actual, which is stoichiometric relationship. Ganon. Now, what is the required here? Okay, blah, blah, blah. Okay, what is it? Okay. Solid magnesium nitride reacts with excess liquid water to produce ammonia gas and solid magnesium hydroxide. If 4.7 liters of ammonia gas was collected at 3 Kelvin of pressure or 1, how much magnesium? Meaning how much? Hala. It's not clear. How much? It's general. Okay, it's not being specified that is a volume, that is a mass, or whatever. So how can you interpret this? Okay, like that. Was consumed in the reaction. Okay, like that. Actually, guys, the question really needs us to think because the match here is really a general term to quantify and to measure the magnesium nitride that was being consumed. It could either be the volume, it could be either the mass, something like that. So how can we confirm that it is a mass, it is a volume? Okay? Like that. Now you have to do the trial and error method first because both volume and a mass are taking the term match in UCH because it's general. Okay, it's not specific whether it is a volume or it is a mass. So question like this, guys, is really grey, G-R-E-Y, but, valid and logical. Only the units are not being presented very well. Okay, this is also part of their objective to really measure if the students learn how to think critically or they try to do it so that they will regulate. They will regulate how many can pass to the examinations by having this kind of approach in presenting the question. Okay, but normally the main objective is to let the students think critically if they really understand the context or the subject matter. Okay, they're really pushing the IQ, something like that, or the analysis, okay, of those examiners and students, because it's really, confusing. How much of the magnesium nitride? So usually we will say, it's a mass. It's also a volume, right? So that's why I corrected at first the word many, because the word many is not really that correct grammar. Okay, you get the point. Okay, so because I take this question in the internet. Okay, so like that. Okay, because I don't have books right now. Okay, in my hand. Ganon. Talaga. And I don't pick also this in the Wikipedia. You know, Wikipedia. Okay, I don't pick that there. I pick in another source, reference source, University of Cambridge. Okay, something like that. Sometimes I choose University of Michigan, Harvard University, pick up their problems there. And sometimes also previous board examination questions in the Philippines. PRC, Philippine Regulation Commission in Chemical Engineering and Physics and Chemistry, something like that. But now, or most of the time na talaga siya, University of Nagaganon, okay? In the, American Regulation Cambridge, hindi ko na alam. Talaga, okay? Okay, it's gonna be like this. Okay, how can we understand this as first and then chemical reaction, right? Okay, so solid magnesium nitrate. Andiyan na naman tayo. Things like this, guys, there's no chemical formula. Okay, so this is really in trouble, right? If we don't know really what's the chemical formula. Okay, solid magnesium nitride. Ay, nakakaloka. Okay, we understand that in the 7A, we have fluoride, chloride, bromide, iodine, astatine, like that, right? And these are all having a -1 charge. Okay, but this nitrate is not belong here. Okay, because this is nitrogen. Okay, it's gonna be group 5A that start with nitride, phosphide, astatine, ganon. Okay, so it's not the same. So it's expected that the charge of nitride is not the same as chloride, bromide, iodide, something like that. So how can you attack the charge of this nitride? This is very, very important because it's not mentioned in the chemical formula. And we cannot balance very well if we don't have the chemical formula. To the point. Okay, so we need to think deeply nitride. Okay, nitride. Charot. So what is the charge of nitride? Now, here you can look at it in group 5A. It could either be 5 and 3. Okay, 5 and 3. You need to say -3 or -5 and think which of this charge is most stable for nitride to react with magnesium. Something like that. So the rule in chemistry, the rule is you have to start with the minimum charge if it is really compatible with the other element. Okay? You need to check also the other element partner before combining as a compound. So we'll start first the smaller. Okay? So just like an iron. Okay, iron, Fe, starts with +2 and +3. Ferrous and ferric. Something like that. Remember that one? And also the gold is +1 and +3. Gold meaning Au, right? And then there's a lot for that, guys. I don't want to mention others. Okay, I'm tired. Okay, so nitride will use -3. Put that here -3. Ganon. Okay, nitride -3. -3. Magnesium. Magnesium, you have to think that it's gonna be in that column 2A. Magnesium, +2. Magnesium, +2. Oh my goodness. Okay, this is gonna be a covalent bonding, right? Covalent, right? Because N will act as a nitrogen, and a halide is gonna be nitride, right? And Mg is a metal. Okay, ganun siya, right? So metal and non-metal, right? Metal and non-metal. Okay? And this is gonna be, sorry, metal and metal. Katubo na kayo guys. It's not molecular compound, it is ionic compound, sorry. Okay? Nakakaloka. Okay? Okay, now, react this +2 and -3, so crisscross, it will become Mg will be the N2, and this 3 will become 3 here. Okay, ganon. Mg3 N2. Correct me if I'm wrong, right? This is the magnesium nitride. right? Magnesium 2 and nitrogen 3, ganon. Okay? It's gonna be like that. Mg3n2. Correct me if I'm wrong. Okay? Like that. Let's check. This is not common. This magnesium nitride. Okay, this is not common. Okay? Like that. So, Mg3n2 na siya, no? Okay, again. Mg3n2 reacts meaning plus. Okay? Reacts meaning combine, unite, add, like that, associate, link. So there are a lot of synonyms in English to replace the word reacts. Okay? Or plus, plus. So a lot. It will be interchanged in the examinations in the future, huh? Like that. With excess liquid water to produce. Produce means also a lot. Resolve, yield. Okay? Like that. So there's a lot of term also aside from produce. Obtain, to obtain, like that. Okay? So we need to be particular also with the verb and the noun agreement. Something like that. So Mg3n2 plus liquid water. Okay, water. Okay? Like that. They specify the water here because sometimes also water will exist as a vapor. Okay? That's why they, emphasize that H2O is a liquid here. Okay? Like that. And this is a solid. So solid plus liquid siya. Okay? And the product will be, how can you guess the product for this? Okay? Now guys, if there's a water, expect the unexpected. Na yun na siya hydroxide sa product. Okay? Because there's H. Hydroxide sa product. Okay, or we will do the double displacement reaction. Double displacement. Okay, ganon. How can we do this? Or we can use the acids and bases, topic, right? Get the point. So we will treat this water as our Bronsted-Lowry acid. Donate proton. If we donate proton to there, okay, like that. Donate proton. What do you call donate proton? Okay, again. So, in this case, we will use the Bronsted-Lowry acid or Bronsted-Lowry so that it makes us an easy. Or we can use also the double displacement, but the double displacement is very complicated because it's water. Okay, like that. Okay? Then, mag-imagine mo tayo rin ako na siya tabo. So, di ba? So, use the Bronsted-Lowry acid. So, Bronsted-Lowry acid will donate proton. O, ganon. So, donate proton. Meaning to say, this H2O is our Bronsted-Lowry acid. Okay? It will donate proton to the nitrogen in the magnesium nitride. O, ganon. Then, klaro kayo that it will produce ammonia. Okay? And the other, since the hydrogen proton is going there already, okay, what's left is the HO. Okay, HO is just the same as OH. Right? Ganon. So, plus OH. Okay? But, since double displacement, we need to attach the negative OH to magnesium. Okay? Because this is also double displacement. Double displacement chemical reaction with a combination of the theory and concept of Bronsted-Lowry acid and Bronsted-Lowry base. Nakaloka. Okay? Now, attach the magnesium here. Okay. Now, since this is ammonia, this is a positive charge here. Okay, meaning to say, ammonia is the conjugate acid. Kaloka. Diba? And then here, there's no charge anymore. This is a neutral. Magnesium hydroxide. Check the charges. OH negative, transpose like that, it will become 1 and 2. And then negative 1 plus 2 is equals to 1. Like that. So, mawala na niya ang negative 1. So, ano na siya? Magnesium hydroxide. Right? So going back to the magnesium here, hydroxide, it's 2. Magnesium going to the OH and OH negative 1 given. What is your formula? Okay, like this. We put parentheses guys because this 2 is coming from magnesium and OH is polyatomic, meaning composed of 2 elements with a charge of negative 1. There's a need to put parentheses. Okay, like that, and then balance the chemical equation. Ganon. Okay, balance na. Okay, so magnesium 3, okay, and magnesium 3, ganon. And then nitrogen 2, oh, ganon. Like this. Hydrogen 6 plus 12. Okay, 12, so we need to put 6 here. Oh, ganon. And oxygen 6 na siya daan dito mga palangga. Oxygen 6, balance siya. Perfect. It's gonna be magnesium nitride solid plus 6 moles of water is equal to 2 moles of ammonia plus 3 moles of magnesium hydroxide. This is the balance equation. Okay, we use trial and error also guys to make it fast. We need to emphasize the algebraic balancing of equation. Okay, ganon. So this will be based on our actual. This one, actual. Okay, now we go to the theoretical. Okay, so what is the best formula to be used since it involves temperature, pressure, volume, so use the PV in RT. Okay, like that, and we are looking for magnesium nitride. Okay, like that. So it's gonna be, we're looking for the volume or the mass. Nakakaloka itong mga problem na ganito guys, okay? So we need to identify na lang talaga siya in the choices of the answer. For example, if the question in the future is multiple choice, because there's gram, liter, because this kind of question guys is unsure. See how much of magnesium nitride, so could it be the volume, could it be the mass, right? So ano na lang siya. Okay, so it's a choice. It's a good shot. Oh. Now like that, so we have this one, so PVNRT, okay, like that. Now, either volume or mass, like that. Volume is more complicated, guys, because no still volume beside pressure, right? Ganon. And then the mass would be a lot easier in the number of moles chuva chu. Okay, we can get that through molar mass is equals to the mass over the number of moles. So there's no such complication. So we will just assume mass is being asked here. Okay, mass of the magnesium nitride, not the volume. Okay, but also it's okay. Okay, like that. Okay, now use the theoretical. So pressure 1.6 atmosphere. Ganon. Okay, we are computing for the ammonia because ammonia is a gas. It will not be applied to magnesium hydroxide, it will not be applied to water, it will not be applied to magnesium nitride. Okay, it's always a gas in this PV in RT. This is the limitation. It's only a gas. Do not apply that to liquid and solid. Okay, since in this chemical reaction, the only gas here is ammonia. So this is all ammonia. Here, volume of ammonia, 4.7, ganon. Okay? Now, universal gas constant na itong gamitin, 0.08205 because liter atmosphere siya chuba-chuchu. Okay? Now, atom temperature is 300 Kelvin. Okay? Now, we have the number of moles. This number of moles of ammonia, guys, take note. This is really theoretical. Okay? So, compute now kung moles sa ammonia. Ganon. Guys, this kind of problem a little bit complicated due to a little bit of confusion of the statements. And then, aside from that, we need to have another new basis of calculation. Because these data are the basis of calculation only in the theoretical formula, not the basis of calculation in the actual result of what is being asked. Okay? Because it is not yet the actual. We still have to employ the chemical reactions to get the actual result of your answer. Okay, now, so for ammonia. Nakakaloka. Listen niyo siya guys. I think, di siya ihatag kaayo. Okay? Like that. Because I don't imagine this kind of problem in the board examination. Okay? It's just very direct to solve. Not, this is not this one. Okay? Like that. So let's check. Okay, I'm going to chuchu 300. Okay. Ganon. Times 0.08205. Okay, 24.6115. Okay. Ganon. 24.615. Nya, ibigay nga na dyan. Talaga, ang ganon. Sa ubos. Okay, because it is beside the number of moles, it will be in the denominator. Now, 1.6 and 4.7. Okay. 1.6, mga palangga. Are you still alive? Okay. I'm very sleepy right now, but still have to manage to do this for the last time. Times 4.7 is equals to 7.52 divided by 24.615. 0.306 moles of ammonia. Okay. 0.306 moles of ammonia. Okay? Now, this is theoretical, ha? 0.36 moles of ammonia, guys, ato siyang na-compute. 0.306 moles of ammonia. Now, this is our basis of calculation to get the actual mass of magnesium nitride here. Okay? Like that. Because we assume that the mass here, MSDH, is the mass, not the volume. In which we tried to explain a while ago, it much complication with the volume. So it's preferably the mass. Okay, we need to say the gram to mole relationship calculation. Okay, something like that. Now we have actual moles of ammonia. Before the second step, we need to determine the molecular weight of ammonia based on the numerization. 17.42, grams of ammonia per mole of the molecular weight. So it's gonna be mole. Okay, and then 17.42 grams of ammonia. Cancel the moles of ammonia. Okay. Now we will not stop here because we can compute only the grams of ammonia. The question here is the grams of magnesium nitride. Now, we go back to step 2, which is the actual stoichiometric relationship. Na always the step 2 din siya, guys, ha? Basta dimensional analysis naman ta. Okay, 17.24 grams of ammonia. Ano na ta? Pila ka mole of ammonia makuha ninyo kayo na sa ammonia. Okay, pila man. Ammonia, pila 2 moles of ammonia. Right? 2 moles of ammonia, and then sa magnesium nitride, pila 2 moles of magnesium nitride. Okay? Like that. Now, if you use this, guys, for example, the spot. Okay, nakakaloka. So, ammonia, okay, and then ammonia is 2 moles of ammonia, right? Like that. Okay, and 1 mole of nitride. Right, that, right? Magnesium nitride, sorry. Like that. So if you will use this one, mga palangga, if you use this one, wala na ko yung microphone. Okay, manabog pa ko ninyo mga palangga. If you try to use this one, it's not practical because you cannot cancel the grams of ammonia and the 2 moles of ammonia. So it's not this, okay? We need to go directly to the relationship. Okay, ganon. So mubalik ka din sa relationship sa actual na yun. Okay? Because it is not practical, that not cancelable all. Sometimes common sense will also work, like that. Not sometimes, all the time. Okay, so 0.06 moles NH3, so we need to go directly to the relationship of the actual. Okay? So, this is really, different, guys. I think so. Okay? 0.306 moles theoretical, actual, ammonia 2 moles. So 2 moles of ammonia. Okay? Ganina, guys, ni gamit ang molecular weight, okay? But that is the case of computing the mass of ammonia. But we're computing for the mass of magnesium nitride, so it's not our concern. We'll go directly to the actual stoichiometric relationship between ammonia and magnesium nitride so that we can compute the mass of magnesium nitride, not the mass of ammonia. Okay. What is the number of moles of magnesium nitride in a chemical reaction? So 1 mole. Okay, 1 mole. Look at the chemical reaction, ha? Di na magpataka. Okay, 1 mole of magnesium nitride. Okay, like that. Tanawin din mo per me. Okay, like that. So cancel lang muna ammonia, cancel mo ammonia. That's the time we have now the 1 mole of magnesium nitride. And this is the time we will use the molecular weight of magnesium nitride. O, di ba? Pila man siya, guys. Kalimot mo ko. So, pila man ang molecular weight sa magnesium? Chat. Magnesium. 24. 24 times 3. 24 times 3. Okay. I don't like to use the calculator. 12, 672. And then 3. No. 2 times 14. 83. Okay. 10, 8. 10, 8. 101. So 101 molecular weight to 100 gram. No. This is 100 grams sa numerator. Kaya man makancel. 100 grams per mole of magnesium nitride. O, ganon. Magnesium nitride. Now, ang mole makancel, ang mabilin grams of magnesium nitride. This is the gram of magnesium nitride. O, pila siya. O, ganon. Okay? So, don't you worry. You can compute also the volume later. Because the match here, how much is confusing. Could it be a volume? Could it be a mass? Kaloka. So this kind of problem really, kakaloka. Okay? So 2 times, ganun siya chupa-chucho. 100 times 0.306 is equals to divided by 2. So 15.3 grams of magnesium nitride is the answer. 15.3 daw mga palangga. Okay? So, 15.3, ato na siyang gamito ng 15.3 grams. So, this is our answer. Okay, 15.3 magnesium nitride. Okay? Now, if we try to use volume, because this is unclear, how much? It's unclear. It could be a volume, it could be a mass. So, how can we relate that? We can never use now katong STP, ha? We need to use again the PV and RT. Okay, PVNRT. Oh, ganon. So we will try, since this is magnesium nitride, okay, we cannot use this PVNRT because this PVNRT is a gas. Unless we will split this magnesium again to an N2 to produce another product, and that will be more complicated. So we will use now the density is equals to mass over volume. Density is equals to mass over volume, and volume is equals to and mass over density. The mass here is 15.3, right? And density. So this is the time density at 300 Kelvin and 1.6 atmosphere. Nakakaloka. So you will try to find that in the table, in the book. Why I said that? We will not force to use the PV and RT gas because it's only applicable to gas. And magnesium nitride is not a gas. Okay, it's a compound that involves the magnesium and nitride. Unless you will heat that again, it produce another product, chupa-chucho. So problem. Okay? Because the point is not applied. So I think for sure what is being asked here is mass only. It's not volume because it will not be practical. Okay, to look again for another table in which it's very not good for examinees or whatever for that particular question. It's not what do you call this one? It's not logical. Okay, to present that kind of question. Okay, but then again, we need to understand how it is being managed to solve. It will be the more important thing to understand. Okay, how you will manipulate the equations and how you understand what is being asked, so that we can come up with the appropriate formulas and equations to solve what is being asked on the problem. Okay, guys, mali siya. Okay? Now, matay volume ng ammonia. Okay, pwede sa gapon siya, guys, naman. Gipangitaan ako option. Okay? Because, if this is the volume, then mga man punta, guys. Okay? We don't know really exactly. Okay, so if you have 4.7 liters of ammonia, what is the liters of magnesium nitride? Correct me if I'm wrong. Okay, nitride. Now, kung naa kay 15.3 nga magnesium nitride, okay, pila man sa lang imong mass sa ammonia, in which makuha na mo dito ato. Okay? Mo-stop ka dito ato, guys. Tinaamang to sa imong reaction diri ganina kato akong gisolve, stop ka dito. Makuha man nimo to ang grams of ammonia. Right na. 0.306 moles of ammonia times the molecular weight in grams of ammonia will be solved. Kasi nakagay check. Okay? Ammonia. So naakay volume of ammonia. Okay? Which is equal to the 15.3 nga makuha nimo. Kay kani siya duha guys, it's actual man siya. Okay, this mass of the ammonia is in the actual scenario. And this mass of 15.3 grams of magnesium is in the actual scenario. And this 4.7 liter is in the initial scenario. This one. Okay, so how much liters of magnesium nitride in the initial scenario? Okay, initial scenario siya. So, ratio and proportion. Okay, 4.7 is to X. And the mass here have also check and mass here check. So we can have now an initial volume of ammonia. Okay, but the question is not yet also true because how much magnesium is consumed in the actual man siya. Okay, so if we have the initial, naka-initial nga volume, ano yun? Initial volume o ganon, naka. So that would be also your base nga makakuha ka sa volume sa final. Sa amay mo anang higayon na. Ato di ka sa kuan. Okay? Makuha na nimo kana naman kay volume initial sa magnesium nitride. Okay? Then volume initial nitride nga na siya X. Volume 2 akakabalo o X ganon. O diba? Okay na. Kibaw man ka nga naakay number of moles of ammonia. Okay? Number of moles of ammonia in the initial nga naa kay 0.306. It's expected also nga nasa kay moles of magnesium nitride nga makuha. Wala na yung initial sa number of moles. Why I choose number of moles, not the mass? Because the volume and the number of moles are directly proportional with each other, not the mass. Okay? So that's why I'm not using the mass. Okay, though I computed already the mass. It's very complicated, right? Okay, so the final volume here, so we have now the number of moles in the stoichiometric relationship. Nakatong 3, ang sa kuan, magnesium nitride kay 1, and then ang katong sa ammonia kay 3. O ganon. So ganon mo magamit. So here, the final man rin ang duha, sabihin ka nga 3 sa nitride. Okay? No, 1. So makakuha final. Yan, very volume initial man to nimo ang kuan nakuha nimo sa magnesium nitride nga imong number of moles sa dito sa theoretical. Okay nga nakuha nimo nga in terms of nakuha nimo nga 0.306 nga moles of ammonia i-relate na nimo siya pila sa moles niya sa magnesium nitride. Makuha na nimo diri ari. Ganon. So makuha na nimo ang volume 2 pod. Di ba? Check. You get the point? So, it would be very, very difficult if we assume this as a volume. How much of magnesium nitride was consumed in the reaction? So, it's gonna be mass talaga siya. Ang ipangita kay dali na kay siya, guys. Very quick and fast and very logical. So, if we try to solve this volume, it can be also solved. But there's a lot of, correlation, like that, blah, 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 initial, final, and then, nakakaloka. Okay? Masakit akong brain cells. Let's go to mass na lang yun siya, guys, na 15.3. Okay? Para way lubo. Okay? Diba? Ako lang i-present the possibility. Okay? Like that. Okay? In a way, it can be shown in the choices A, like that B, like that C, like that D. Normally naman, guys, po siya, no? In the question also, if the question like that, the choices also are uniform. For example, what is the volume of blah, 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 so and so. Normally po sa question, all are written in the same unit. Why mo lubog? Okay? That's what I've observed in the actual examination. For example, trying to ask the volume. Also, the choices are volume. It matters only now the numerical figure. Okay? Now, in that case, if all choices are volume, in this particular question, then you need to use the other option, not the mass. As simple as that na lang talaga siya. But if it is grams there, then Bingo, kalas. Ang how much there is gram, not the volume. Diba? So, meaning to say, this will not really come out in the actual because it's really confusing. You get the point? Ang importante na makasabot pa. Okay? Ganun siya. Ano ba siya? How much of magnesium nitrate will be consumed? The word much, guys, is general. You know? General. M-U-C-H. Mas okay pa ang how many. Because only counting how many pieces, how many units. So it could be understandable. How many, like this, calculator. So meaning to say units, pieces, quantity. But if you say how much, pagtalunan pa siya. At it could either be volume, it could be either mass. Okay? That's because this is chemistry, like that. But if another way around, talking about money, so of course money specifically. How much price? You will never say volume because it's already money, right? Gimension dito. But this is chemistry. Okay, it either be volume and it'll be a mass, but not money. Something like that. Okay, you get the point. Oh, muna siya. And then if you try also apply to money, it's not many also. How many? So it's the pieces of the items already, not the price. You get the point? So grammar. Okay, English grammar will be very, very helpful to analyze the problem. Okay, like that. You get the point? O, ganon. Okay, guys, muna siya yung mga timanan kesa to face problems in the future. Nabay na siya sa second day sa physical and chemical principles o sa mga physical chemistry and thermodynamics. Something like that. And sometimes also unit operations, but not that really that much about like chemical reaction, ha? So, usually in kinetics, but you know, it's not concerned really with the amount. It's concerned with the rate of the reaction. Also, rate, R-A-T-E. Though it involves chemical reaction, but the main concern is the rate. The rate of the reaction. How fast and slow the chemical reaction really is. Not matters on the amount. Okay? Amount, kaya ka naman mga mass, mga volume, ganun. Okay? So, most of the kinetics, so, but helpful siya sa thermodynamics, physical chemistry, general chemistry lectures. Organic chemistry don't have calculations. Only theory, chuba-chuchu. Okay? Theory. Not really compute like that. Okay? You got the point? Okay? So that's it for tonight. Thank you so much for listening for the last vlog number 5. If you can comment, like, and share, you can. And if you're not subscribing to my channel, you can subscribe. And you can click for the notification bell for some newest updates of Emma Singer. Channel guys. Bye-bye. God bless everybody. Ganon. Kaloka. Diba? Nakakaloka yung, yung problem.